is the chemistry of the class 10 standard NCRT board, right? The chapter name, that is nothing but it's a chemical reaction and the equation. I hope you already means have an idea about the elements, how many elements are there or how they are classified, as well as what is the periodic table. So these essential things are very important. If you want to study about this chapter, we have to understand what are the types of the elements we have, and from that the elements, which are the metals, non-metals, their atomic number as well as the atomic mass number, their valency should we know about it, right? So basically there are total 118 elements as per the modern periodic table, and we have the total 18 groups and the 7 periods, that is the horizontal rows, and the groups are nothing but it's a vertical column. So in that chapter, first of all we have to means know that which are the basic examples as we are aware about it. For example, that is the milk, whenever we kept the milk for a long time open in a sunlight or open in the atmosphere, so that time after certain time the taste of the milk get converted into the sour taste. As well as the another example, that is the iron. We keep the iron materials outside our home or in our home, where that iron is react or just kept open it, and if the water is means falling on that iron material, after certain time you can see there is a rust is formed, or the reaction between the iron and the atmospheric oxygen. After that you will get the ferrous oxide as well. Again the grapes, as we know that the fruits we kept for a long time automatically means they get the ferment. Then in our human being or the whatever the living organism, we have the important life processes such as the digestion and the respiration. So digestion is nothing but whenever whatever the intake we have taken, likewise the food materials, the carbohydrates in our bodies, that particular the nutrients we get it, and how the ATP or the energy is formed, and as well as means the respiration. We have the quite simple idea about the respiration, that is the inhale the oxygen and means exhale the carbon dioxide, but it's not a very simple process at all. Whenever we study about the cellular respiration level, means at the cell level of the human body, that time you will get the idea. Whatever the glucose in our body by we are getting from the food, that glucose get react with whatever the oxygen we intake, and along with the water molecules inside that reaction. After that you will get the product, that is nothing but it's a first one, that is the carbon dioxide that we exhale. Then again the next one, it should be the water molecules, water vapors are there, and the third one, that is the important, that is nothing but it's a ATP form of the energy, adenosine triphosphate, that is the energy molecule will get from that reaction. So all those things we are quite aware about it, right? So then the next topic, it should be the indicators of the chemical reaction. So when we say that the chemical reaction is occur there, or how can we identify it? First one, their state, means if there that particular, it should be the singular state. For example, we have the iron, but after the corrosion it forms the oxides of the iron, right, or loses the electrons. Then if there is any color change, you can see the milk. Earlier it should be the purely white in form, but after that you will get the yellowish color, or the layer some layer is formed in that particular milks. Then the evolution of the gas in the some reaction, after the reaction the some amount of the gases will be evolved, so that time again we can say. Then the change in temperature, so which are the means earlier the temperature should be lower, but after reaction the temperature will be increased. Then the next one, it should be the chemical equation. So whatever the reaction occur between the different elements, and you will get the another product. So it should be shown by one particular equation, that is nothing but it's a chemical equation. For example, we have the one element that is the magnesium, and the second one it should be the oxygen. So whenever the reaction occur, after that you will get the magnesium oxide as well as their symbols as shown in that particular PPT. That is, the Mg is denoted by magnesium and O2 is denoted by oxygen. And after the reaction, this magnesium and oxide, which is the left hand side of the reaction, we called as it's a reactant. And after reaction there is a product is formed, which is on the right hand side. So you can see the example as well. Now after that, the next topic, that is nothing but it's a balancing the chemical equation, right? So it should be, means as per the chemical equation, any reaction should be balanced, otherwise this reaction is not completed at all. That first one is nothing but it's a law of conservation of mass. That is, the mass can neither be created nor be destroyed. Means on the left hand side, certain gram of the reactants are there, as similar on the product side, similar amount of the product is there. The first one, that is we have to write down the skeletal equation as it is. There is a ferrous, that is the iron, then iron is react with a water molecule, water. After reaction you will get the Fe3O4 and the H2 gas, right? That is nothing but, first of all we have to check, means left hand side as well as the right hand side, which are the elements are there. And after that, means once we make a table there, and we have to balance it one by one. So here we can take it, first one it's a LHS and here it's a RHS, means of the equation. Generalized way, I just explain in a short. In the first one there is a Fe element, okay. Fe is nothing but that is the iron. If you check it on the LHS side, there is a 1, and RHS side there is a 3. Then the next one, it's a hydrogen. Hydrogen on the LHS side, that is the 2, and here it's a, that is the again 2, means hydrogen is balanced. And third one, it's a oxygen. On the left hand side there is only 1, and on the right hand side you will see the 4. Now we have to balance this chemical reaction. So how can we balance it in general way? So here it's a Fe3 on this side, and here it's a Fe that particular. If we write the Fe left hand side in front of this reaction, so will that particular, we have to write down the 3 in front of that, means we'll get the thrice Fe. Here it's a thrice Fe, okay, plus H2O, and we'll get Fe2O3 plus H2, right? So first one, the ferrous, that is the iron, is balanced, we can say it. And the remaining one, that is the oxygen. Here it's Fe2, Fe3 and Fe4 here, okay. So some mistake is there as per the given one. And what we have to do, the ferrous is balanced here, and the oxygen we have to write down here, means oxygen totally equals to how much? It's a 4 level, so we write the 4 in front of H. Now the hydrogen, it becomes means 4 to the 8, okay, so it becomes 8, so we have to balance it again. Here it's a, we write the 4 in front of the H2, so you will get the required equation, right? So in this way now you can measure it. The hydrogen here, means hydrogen, it becomes how much? It's a 4, that is the 8, and the oxygen again, it's a nothing but it's a 4. Then again here it's a, on the right hand side you will check, means which are the things are there. So Fe3 is, that is balanced. The hydrogen again, it's a 4 to the, so we have to multiply 4 here, so 4 to the 8 you will get. The oxygen already balanced. So in this way we have to balance the chemical reaction. Now the next one, that is the first reaction, we can say it, the type of the chemical reaction, the combination reaction. That is the combination, it indicates that whenever we have the two or more than the two reactants on the left hand side, but you will get only one product, single compound, that time we can say such a reaction is the combination reaction. We have the example as well, that is the calcium oxide and the hydro, that is the water is given. So after that you will get, that is the CaOH2. Then the second one, decomposition. The decomposition reaction is nothing but such a reaction in which whenever something is decomposed, means it will be formed in the multiple parts. It is the broken down. That is why in that reaction only one reactant is there. After that we'll get the multiple products. That is the twice AgCl. That is the silver chloride. You will get the silver and the chlorine gas. After that the third one, that is the displacement. Displacement is nothing but whenever we have the two compound, means one compound and a single element is there, and you will get in case of the third reaction, that is the A plus BC. If A is more reactive than the B, so automatically what happen, A takes the position of the B, and therefore you will get the AC plus B. In that example, if you check it, that is the AP plus CuSO4. Fe, that is nothing but it's a iron, and CuSO4 is nothing but it's a copper sulfate. So iron is more reactive than the copper. So automatically what happen, the iron will take the place of the copper, and you will get that particular thing. So FeSO4 plus Cu. Then after that the double displacement reaction. In that reaction, what happened means we have the two compound. So there means in that reaction they are exchanging their ions. In the first one, that is the sodium Na2SO4 plus barium chloride is there. After that the sodium took place of the means Ba, and that Ba takes the position of the sodium. Then we'll get that is the double displacement, because we have the two compound, and in both compound whatever the metals are more reactive, positive ions exchanging their places. After that, that is the redox reaction. In that reaction alternately oxidation is occur along with the reduction occur. Then the oxidation and the reduction. Oxidation is nothing but it's a whenever any single element join with the oxygen or gains the oxygen or the loss of the hydrogen, that time we can say it's a, that is the oxidation. And the reduction is nothing but if we have the oxidized compound and the oxygen is removed from that compound, or the gaining of the hydrogen gas, that is the reduction. So CuO, that is the copper oxide, is react with the hydrogen, you will get the copper plus water, and CuO is reduced. Whenever we reduce the CuO, that time you will get the separate hydrogen. Then whatever the everyday effects on the reaction, first one, it should be the corrosion, the rusting of the iron, tarnish or the tarnish on the silver, the green coating on copper. These are the everyday, means if we keep the things for a long time. Then the rancidity is nothing but in general way, if we keep the vegetable oil for a long time open in the atmosphere, that the fats and the oils get oxidized, and that is why we'll get the bad smell as well. Then the prevented by antioxidant or the nitrogen flushing. In summarized way, if we think about it, so chemical equation